So having spent a lot of time recently playing with the plug and play process within DNA Centre, I thought it might be useful if I made a quick video to go through some of the pain points and the workflow on how to get this set up. It might be of use to somebody out there. So this video is quickly just going to go through the components that take place when running a plug and play job. I will make a second video to keep this video shorter on how to actually configure it using the DNA Centre, and I'll go through all the GUI options and the CLI configuration required on the device. So what is plug and play? So plug and play, basically, in a single line, it's a way to provision a new network device from a central controller, a plug and play server, via having the plug and play agent, the device, establish a line of communication with the server on initial power up. And this is basically the quick workflow and a lab I have to test this on. So this is my test bed. I have a switch set up as a DHCP relay, and then there is IP communication set up between the plug and play client, which is going to be placed here, and the Cisco DNA Centre. I think I've just got some OSPF or something running here. This is my device here. It's cabled by one of the front ports, and the plug and play agent is running on this device. The plug and play protocol itself will communicate via HTTPS with the plug and play server, the DNA Centre over here. And as mentioned, for this to work, there needs to be reachability between these devices, and the plug and play agent needs to know who is the plug and play server, and this is gleaned via DHCP or DNS. When using DHCP, the plug and play server's IP address is offered in the form of option 43. This option contains the IP address of the plug and play server itself. So as long as the agent over here is given an IP address and a gateway and can route between the agent and the server, you should be fine to run plug and play. This is an example of setting this option in a Windows 2012 server. However, if not using option 43, you can leverage DNS. The same reachability is needed. The agent still needs to be able to route to the server. However, how the DNS option works is the agent tries to resolve plug and play connect.domain name, where the domain name is the domain name that's offered by the DHCP server. So sure, you have an A record for this. In my case, the DHCP server is also the DNS server. So how does this communication work? Okay, so once the plug and play server IP is known, the agent can establish a line of communication with the server via HTTPS. As part of the initial exchange, a certificate is installed on the agent for this HTTPS protocol to work. In our example, the plug and play server is the Cisco DNA Centre, and this is the controller that's responsible for controlling device deployment. This essentially does two things which are of interest to us today. It pushes down software images, as you can see here by this nice little animation, and also the day zero configurations. So these day zero configurations are the ones that we write within the template editor application on the Cisco DNA Centre, and we'll get into the details of that one shortly. Okay, so once the plug and play process is completed and the image has been upgraded and the initial configuration has been pushed down, the device is then handed off to the DNA Centre inventory application. Now, this needs to add some additional day zero management configuration. This includes username, password, protocols used to manage the box in SSH telnet, plus some SNMP read-write strings. And these are all pushed as part of the day zero onboarding process. But note, they're not configurations that are pushed within the templates we write under the template editor. They are configurations that are pushed after that template has been pushed, and they're pushed via the inventory application. And then going forwards beyond plug and play, it's noteworthy, device management can be done as part of the day N device lifecycle. And really what we're saying here is that any subsequent templates required for a device can be created in the template editor and pushed to a device or group of devices. For example, One might want to deploy a new loopback 5 on every device. You could write that in a device template and push it out to a bulk of devices. Or a more real-world practical use would be scheduling bulk software upgrade to multiple devices for your new current gold target image. Okay, that's just a quick overview of the process. I want really to spend most of my time going into how this all works, so I'll create a separate video to this one. And the testbed for that will be DNAC 131 as the plug-and-play server. Plug-and-play agent for this test will be the 1001 ASR on 16.9.3. If you want to set this up yourselves, it is possible to use the CSR 1KV if you can't actually get hold of real tin to do some testing. Anyway, thanks for listening, and I'll see you on the next video.